Welcome to the Java recording for Exceptions Handling and Assertions unit. And you can see that this is the essentially week 6 of the course, but it depends on what block you're taking the course. And in this unit, you have the Exceptions Handling quiz, then you have the Assertions quiz, as well as the write-up. So 3 things to do in this unit. So I'm going to scroll on down and get started on it. So Exceptions Handling and Assertions. And one thing I want to mention before I jump into this, some of you have fallen behind on doing the quizzes. Remember, this course is based on the quizzes for the most part and the write-ups, and then at the end for the final project it's going to be a written project on programming, and it's going to be at least 200 points. It might be 300 points, so it's going to be a major part of your grade, so you'll need to keep that in mind as we get towards the end of this class. So I'm going to scroll down. Let's get into the write-up questions. So on the introduction screen, what are the 2 ways errors can occur in programs? So here's the introduction screen. And as you can see, when a program doesn't work the way you intended, there's at least one error involved and sometimes more. You have to go through the program code line by line to find the errors. So that would be a faulty program error. But sometimes errors happen when the user does something wrong. So those are the 2 ways. So there's an error through faulty programming or an error when the user does something wrong. Those are the 2 ways that errors happen in programming. So in this unit, we're going to look at exceptions handling. And exceptions, they're called assertions. I mean, those are things that happen that cause the program to not work properly, something that is incorrect. And after you go through this unit, be able to understand exceptions handling, ability to handle multiple exceptions, have knowledge about assertions, comprehend what threads are, explain different types of threads used in Java. And remember, don't go by this, always go by the grade book. The grade book is most current. And the discussions, we're not doing discussions, so just skip over that. Okay, back to the write-ups, we can jump into section A. Okay, define the word exception as used in programming. List the 3 types of exceptions. What is a phrase used to tell the user that an error has occurred? Well, I need to fix the word tell, don't I? I need to fix a couple of things here. There we go. Okay. Just fix those for you. So define the word assertion, list 3 types of exceptions. What is a phrase used to tell the user that an error has occurred? What is a term for an exception that is not a predefined exception? So section A. So an exception is an unusual event beyond the control of the program. Oops. Yeah, that's section A. Exception handling can automatically invoke error handling routines. Programmer can specify the list of exceptions that can throw or invoke part of a function. So you can understand the meaning of exception, understand exception classes, understand exception statement syntax, comprehend the rules for try, catch, and finally, understand try, catch, and finally, define new exceptions, handle multiple exceptions. And I guess I need to go back to that question. So define the word exception. Looks like we talked about that. You have 3 types of exceptions. So 3 types of exceptions. There's a compile time error, which means that as a program compiles, then you get the error. Then there's the runtime error, and that one happens during the run. So you can see that example, that would be division by 0, and there are other different things that can happen. Then a logic error. They're most difficult to find. They just produce unexpected results. So then you have to look at your results to test the program in different ways and then see what the logical error might be. So you might be divided by the wrong number or something like that. So the program won't throw an error, but the answers would come out incorrect, right? So those are the 3 types of errors. So in exceptions in Java, so exceptions are errors that occur during the program execution. They disrupt the normal flow of the program, right? So we've talked about that before. And how those are handled, that's called exception handling. And when you do exception handling, then you do what's called a throwable class. So you end up creating these exception classes within the program. And you can see that there's the runtime exceptions and the input-output, the I/O exceptions. And you can see they have them categorized down here, the types of errors that can occur with those exceptions. A lot more about the different types of exceptions. So the runtime exceptions, you can see the variety of them. And this is nothing you need to memorize, but it would be nice if you just kind of knew what some of these types of errors mean and the categories in which they fit. And then the I/O, the input-output errors. Exception handling. So an exception statement is what you'd use. There's 3 commands that you have that are part of it: try, catch, and then finally. And that's a full exception statement. So you see that this is the try. And then there's the catch. So you see how the catch keyword is used. And then finally there's the finally block. And this is executed on successful or unsuccessful execution of the program. So the finally block is what would actually give the error to the user that would show up on the screen. Here's a practice activity for exceptions handling. So go through that like you always do. So here's a sample program with the try, catch, and finally. So if you look at this, you can see they have the program set up. And here's the try statement, the catch statement, and the finally. So there's the try block, just showed you that. The function of the try block. Monitor whether z equals x divided by y produces an error. So that's what it's monitoring right there. Is that going to produce an error? The catch block catches the error if it occurs. And then a few notes about the program so you can read through the notes. So you've declared 3 variables. Value of x and y are 20 and 0. And then it does the division. So you can see how this will explain what this program up above does. There's a tutorial on exceptions. So you probably want to go through that. Let me go back to the write-up to see what the other questions are. Was the phrase used to tell the user that an error has occurred? What is the term for an exception that is not predefined? So I don't think we've hit those yet. Actually, we have. Let me go back. Trying to remember where that question was. Okay, sorry, a little mixed up there, but I just want to go back to the write-up question. And it says, what is the phrase used to tell the user that an error has occurred? Well, that's on this screen right here. So informing the program user that the error has occurred is called throwing an exception. So that's where you get all this information about throwable and exception and things like that. So that's the phrase right there. It's called throwing an exception. So that is where the error message would come up. So we've gone through these pages. Talked about exception handling, and you have that to go through. We looked at this program. So here's a tutorial about exceptions, so make sure you go through that tutorial like you do on all the programs. And now there's another type of exception called user-defined. So Java creates its own exceptions, but you can also create your own rather than using the predefined. So user-defined. And the reason you would want that is like right down here, maybe if you're doing a program where people type in their age. And there's hardly anybody over the age of 25, so you would want the program to accept numbers from 0 to 125, right? So you would specify that. Now Java doesn't care what numbers people put in unless you tell Java to care about what numbers people put in. So that's where you would use a user-defined. The other thing could be like if you were having a person choose M for male or F for female in a program. And if they choose something other than M or F, then it would give them an error, a user-defined error that you created. So remember, there are program-defined within Java and then user-defined exceptions. Now, throw statement, this talks more about the throw and how it can throw an exception to the user. So you have to, it said, make a throwable class. And we looked at that before, so you can see how you make the throwable class, and then you would have all the coding within that to catch the exception. Now, multiple exceptions, so there's a little tutorial about multiple exceptions, so you want to take a look at that. Here's a practice activity. You can give this a shot. You can try it, and then you can go look at the real answer right there. The drag and drop activities that they always have. And then finally, this is what we looked at as we went through this part of the unit. Then you have the exception quiz right down here. There's the exception quiz preview that I always provide. Let's go back to the write-up. Now we're at section B. What keyword is used to catch errors before a program finishes? What does it mean that an assertion statement must contain a Boolean expression? In section B, so Java, you use a conditional statement if you want the program to check something, such as whether a given number is greater than 100 or not. You can also use the assert keyword to check the condition during the development process. So the keyword is the assert keyword. With the assert keyword, you can catch errors before the program is finished. So wouldn't that be nice? Rather than having a person run all the way through a program and then give errors, the assert will help you show errors as you go along the way. So we're going to look at understanding the need for assertion, the types of assertions, use assertion in programs, enable, disable assertions at runtime. So why use assertions? Well, they're defaulted, they're disabled at runtime in Java in general. But then you can make it happen during the writing of it. And assertion statements must contain Boolean expression. What that means is that they must allow the result to be true or false. Because that's what Boolean is true or false. Does it meet the condition or does it not meet the condition? So if it meets the condition, so when the statement is executed, it must meet the condition of true. If not, then the user will get the assertion error. So that's what Boolean means, is that the result must be true or false, yes or no, etc. Like does the answer fall between 0 and 125? Either yes it does or no it does not. It's either true or false, right? And if it's false, then it gives an error. So you have to declare the assertion. And this talks about the syntax, just like we've seen in the class. You can see right here what this one is going to do is it's going to look at values. So that's going to be the comparing. So that would be the yes or no, the true false part, right? So you can see all the information about assertions on here, different forms of the expressions. Here's an assertion practice activity, so go through that. So remember, assertions are disabled at runtime, but you can enable the assertions to run as the program runs. So these are the Java commands that you would use to make assertions run or not. Here's an example of an assertion. In this example, the import Java utility scanner package is used. The scanner is used to scan text using delimiters such as white space or text given. In this case, since a delimiter is not given, it uses white space. So this one is just checking to look at input from the user. And this check actually checking whether the given value is greater than 1,000. So you can see right here, the given number is greater than 1,000. So if that is, then it's going to come back with an error, right? Here's a little tutorial on other assertions, so go through that. and some program check. You can mess with that if you want to, give that a try and see the results. So we looked at the need for assertion types, how to declare, and how to enable. Now this says take the section quiz. We don't have a section quiz for this, so don't worry about that. Okay, go back to the write-up. So we answered both of these questions. And finally in section C, what is the thread of a program? Listen and explain the two types of threads. So section C. Now we're going to talk about threads. So a thread is the path of execution, or the way the program goes, right? The steps it makes, the sequence of steps and events. That's what a thread is. And there are two types of threads. There's single threading and multi-threading. And we'll look at what they are. So we're going to understand the meanings of threads, understand thread states, declare and define threads, comprehend the rules of threads, the need for threads, and examples of threading program. So different types of threads. So threads help make the program model simpler. And we've been looking at very basic threads, but there are much more complex ones. So declaring and defining. So a thread can be declared and defined in two ways. So you can use the thread class, or you can use a runnable interface. So you can look down here and you can see different ways that threads can be done. Now there are two types of threads. So the one question said, question 9 and 10, explain or list and explain. So single thread system, only one of the programs, one line executes at a time. So in single thread, you just go sequentially, line by line by line by line when it executes. So this is going to do this line, then it'll do this line, then it'll do this line. Then here's a sample of single thread. So you can see with single thread, it does this step, then this step, then this step. So one step at a time. And this does multiple. It does not multiple threads, but it goes through it a number of times. But still, it does one step at a time. But now there's multi-threading. So multi-threading allows the user to write the program to perform many functions simultaneously. And you can use much quicker, much more smoother programming if you use multiple threads, multi-threads. So you can see that in this program, so instead of it doing line by line, it does things practically simultaneously. I mean, as far as our uses, it looks like it's simultaneous, exactly at the same time. Here's a discussion on threads. We don't do the discussions. Here's a multi-thread program, so you can take a look at that on a multi-thread program. So you can see it's running this thread and then this thread, runs them at the same time. Some advantages of threading. So they're useful to improve application performance for parallelism. Parallelism, which means things running at the same time, running side by side. The part of the CPU that runs the thread ends up being a single space, so then it can be much more efficient. Your computer runs more efficient. So you can see the different reasons that you would use threads. Program and thread. Of course, you can do this if you choose to. Here's some Java tutorials you can go to, but the programs are optional. And finally, the unit project. That's optional, doing the unit projects. You can do that if you like. Of course, it says down here, optional, optional. So that is all that we have for this week. And actually, I need to go back because this says the quiz preview, and this says 2 quizzes, and actually there is no assertions quiz, so I need to adjust that. There's really just the one quiz this week. I remember I deleted a couple quizzes in this class because the way the quizzes were set up, they were to do programming lines, and it was just impossible. In the past, it's been impossible for students to do the quizzes well. Okay, so that's all I have for you for week 6. So week 6 is a pretty easy week, so you should be able to catch up on previous work. You need to get those grades up, please. Many of you are down in the C and D range. There's no reason you shouldn't be in the A and the B range. So I look forward to your work coming in. Thanks, everyone. Bye.